Good morning. It is fantastic to see you all here, so thanks for coming. So during this keynote, I am going to talk about things we've done at Databricks since we started it, its impact on the community, and some plans for the future. So when we founded Databricks, one of our key goals was to drive the growth of the Apache Spark ecosystem. And thanks to you, our fantastic community, our partners, I am happy to say that we exceeded our original lofty expectations. Today, Spark is part of every major Hadoop distribution: Cloudera, Hortonworks, MapR, IBM, and Pivotal. In addition, Spark is now packaged in non-Hadoop distributions, such as DataStax. It's also available in Amazon AWS, so now you can use Spark to process your data in S3. But we want more than wide distribution. What we want is that every Spark user to have a fantastic experience. But in order to achieve this goal, we have partnered with several companies to distribute Spark, and we are working closely together to make sure that every one of their customers is successful. We are delighted with our partners, Cloudera, DataStax, and MapR. And please check the keynotes to learn more about how we are working together, how we help to make the customer successful.
Okay. Hey.
Finally, today, I am very pleased to add a new logo on this page. It's a company everyone knows about it, SAP. And for this, please let me invite Ayaz Kazi, the SVP of Platform Strategy at SAP, up on stage to say a few words. Please welcome Ayaz.
Is this on? Can you guys hear me? All right. I won't take much of your time. This is an honor and pleasure to be here with you guys. We see the growth of something big here with Spark, and this is a momentous occasion for us at SAP as well. And yes, what you're seeing is the first step, and to understand what we're doing with Spark and how we are bringing this into the SAP family, come see the keynote that was under TBA for tomorrow, 9 a.m. in the morning. And we have been delivering a platform, in-memory platform for big data management with transactions, analytics, a myriad of other capabilities. Come see how these come together. I won't take much more of your time. Thank you very much, Ian, for having me up on stage.
Thank you. Over the past year, one development we've been particularly excited about was seeing a large number of applications being developed on top of Spark. And to help the growth of this nascent application ecosystem, in February, we announced a certification program for Spark applications. The program has been very well received. Today, we have more than a dozen applications being certified. In addition, last week, we have launched a certification program for Spark distributions with 5 initial distributors: DataStax, Hortonworks, IBM, Pivotal, and Oracle. These 2 certification programs together make sure that every certified application will run on every certified distribution. This way, we introduced a compatibility layer, the Spark API, between the Spark application and the Spark distributions. And in the process, we reduced the risk of fragmentation for Apache Spark. Both certification programs are free. Moreover, scripts for certifying the Spark distributions are created by community and are open source. Therefore, anyone can use these scripts to certify any Spark distribution. training has been always a centerpiece of our efforts. At Berkeley, we've been teaching Spark since 2012 through AMP camps, many of you attended, or Strata tutorials. Since we started Databricks, we ramped up our training efforts. Since the beginning of this year alone, we trained more than 400 people. And we just launched a new training program, and we have already held workshops in 5 cities. Also, I'm very happy to say that our training session on Wednesday has been sold out. Over 300 people registered. So thanks all of you again for making this possible. So in summary, over the past year, we made significant strides maturing the Apache Spark, like you saw in Matei's talk, driving its adoption, and fueling a nascent application ecosystem. However, when we started Databricks, we had much bigger ambitions. We wanted to address all the challenges, the pains that today data engineers, data scientists face when working with big data. And to convey this to you, I am going to show a short video in which several data scientists and engineers we are working with are going to tell you in their own words about their pain they experience every day.
Data science became a buzzword about 3 years ago, 2011. And I loved that moment because it gave a name to the thing that I'd been doing for years already.
One of the easiest ways that anyone can make a machine learning task easier is by throwing more data at it. And so I'm always on the lookout for ways that will simplify my workload in terms of harnessing and marshaling more data to meet the tasks that we have in front of us.
It's a huge amount of data, it's a lot, right? So storing it, maintaining the hardware infrastructure, lots of disks and clusters. There's always failures. It happens like every week.
I'm never confident that, with my background in statistics, I've delved far enough in cluster management, network architecture, et cetera. It fills me with anxiety, at least, the idea of like, okay, I've just written this TSV exporter. Am I sure that my TSV importer on this, in this whole other, language or framework is anticipating the exact same format?
MySQL works very well until your database gets above a certain size. Matplotlib, Pandas work really well for data as long as it fits in memory. If you get bigger than that, then you need a new tool. Switching back and forth between those can be really painful.
So all of those things kind of make me itchy as a data scientist. Like obviously if I could just rub a lamp, I would just say like, I don't want to have to worry about any of the distributed aspects of this whatsoever.
By the time I get some results, I realize I actually wanted to look at something in more detail. If I would be able to take that down to minutes or even seconds, I can do way more,
We need tools for asking questions that other people aren't asking. We need to slice and dice the data in lots of different ways. And a lot of the traditional infrastructure doesn't meet those needs directly.
So let me put these pains, challenges in a broader context. When you look today around, on one hand, you see companies like Google, Facebook, Amazon, and Twitter, who have been hugely successful businesses leveraging their data. On the other hand, you see many other companies, organizations that collect data. And they collect this data with one goal in mind: turn it into value. This means improving their revenue, reducing their cost, in one word, improving their businesses. However, turning data into value is hard, very hard. And to see this, you should look no farther than companies like Google, Facebook, and Microsoft, which today spend billions of dollars every year to build, deploy, and run big data tools, applications, and systems. So let me talk a little bit about these challenges. And I'm going to do that in the context of a big data pipeline. So say your company starts a big data initiative. Then, depending on who you are in that organization, you are going to be tasked to do one of the followings. Build a Hadoop cluster if you are part of the IT organization. Then, you are going to be asked to build a big data pipeline on top of this Hadoop cluster if you are a software engineer or if you are a data scientist. And finally, you are going to be asked to use this data pipeline to turn data into value by getting insights and building big data products. And you are going to be asked this if you are a software engineer, data scientist, or data analyst. Unfortunately, every one of these tasks is hard. Clusters are hard to set up and manage. Actually, in many cases, it takes between 6 and 9 months to set up a Hadoop cluster on premise. To put together a big data pipeline, you need to combine a zoo of tools which are complex and hard to stitch together. And after you are done with that, the tools themselves are still hard to use. So turning data into value remains a continuous struggle. So let me go a little bit in more detail and again present these challenges in the context of a big data pipeline. And here it's an example of a typical pipeline. And many companies, once they set up a Hadoop cluster, they want to consolidate their data in Hadoop HDFS. Their data represent logs and data from other sources. However, this data is often noisy, unstructured. So once you get it, the first thing you are going to do, you are going to start cleaning it, transforming it, create some tables. And you are going to do that using a bunch of MapReduce jobs to do this ETL, extract, transform, load. Next, once you have this data nicely and cleaned, and maybe a few tables, you are going to start doing exploration. You can use Hive to process the data directly from your HDFS. Or if you want interactive query processing, you can use one of the new tools or systems developed recently, like Impala and Apache Drill. Or you can ETL some portion of your data in a more traditional database, and then use database tool in order to query this data. Once you do exploration and you compute a bunch of interesting metrics, you want to take these metrics and create some dashboard and reports to share with the other people in your organization. And in many companies, this happens in an ad hoc manner. For instance, 1 or 2 engineers spend a few months to create these dashboards and reports. Alternatively, you can use one of the existing BI tools, such as Qlik or Tableau, if their capabilities fit your requirements. But just exploration and pretty dashboards is not enough. What you really want is to get deeper insights. Remember, you want to improve your business. This means you are going to start doing advanced analytics. That is, to employ sophisticated algorithms like machine learning and graph-based algorithms. And for this, you are going to use new systems. Maybe Giraffe or GraphLab for graph processing, Mahout for machine learning, or maybe a sophisticated tool like R, although in this case, you are going to process only a subset of your data because R runs on a single machine and in many cases on a single core. And finally, once you get the insights, the next thing you'd want to do is to productize these insights. You want to build data products, such as recommendation system. And you do that again, or in many cases, as a Hadoop MapReduce job, which runs periodically. So you can see this is a complex system, a complex pipeline. in which you need to integrate these disparate, complex tools. And even after you are done with that, the data still remain hard to navigate. And it's even harder to build and deploy applications. At Databricks, we want to address all these challenges. Our vision is simple. Make big data easy. Easier to use than ever before. And we are doing this by addressing every one of these three challenges. To alleviate the need to set up and manage clusters, we are providing a hosted platform, which makes it super easy to launch and manage clusters. To obviate the need to integrate a zoo of tools to build a big data pipeline, we are leveraging Apache Spark. Like Matej said, Apache Spark unifies the functionalities of many of the existing big data tools and systems. And finally, to dramatically simplify the ease of use of these tools, we are going to provide a powerful workspace which allows users to interactively query and visualize the data. So today, we are very happy to introduce our first product, Databricks Cloud, which will rely on all these solutions. Databricks Cloud is based on Apache Spark and includes the Databricks Platform and the Databricks Workspace. Next, I'm going to talk about each of these components in a bit of more detail. Databricks Platform is a hosted platform which currently runs on Amazon AWS. We are looking forward to our support for other cloud providers, such as Microsoft Azure and Google Compute Platform. Databricks Platform includes a sophisticated cluster manager, which allows you literally to instantiate a new cluster in seconds. And in addition, it provides everything else you need automatically. It provides isolation, security, it instantiates fully configured clusters, fully configured up-to-date Spark clusters. It allows you to dynamically scale the cluster size. And finally, it provides an easy-to-use yet powerful import capabilities, data import capabilities. Like I mentioned, Databricks Cloud is built around Spark, which unifies the functionalities of many of the existing cluster computing frameworks. In particular, Spark unifies streaming, SQL, machine learning, and graph computations in a single system under a single API. Finally, to dramatically simplify data analysis, we are introducing Databricks Workspace. Databricks Workspace consists of three applications: notebooks, dashboards, and a job launcher. The notebooks provides users the ability to interactively query and visualize the data. Currently, it supports Python, SQL, and Scala. So you can write and query the data, process the data in any of these languages. You can also intermix the languages in the same notebook. In addition, the notebooks provide online collaboration. So multiple users can work together in real time on the same notebook, on the same exploratory session. Once you created one or more notebooks, you can take the most interesting results and you can create a sophisticated dashboard. You can do that by using a sophisticated yet easy to use dashboard builder. And once you build a dashboard, you can publish it to other people in your own organization or to your customers just by the click of a button. Finally, Databricks Cloud provides you a job launcher, which allows you to run arbitrary Spark jobs programmatically. In particular, you can schedule a job to run periodically, or you can schedule a job to run when its input changes. So now let me go back to this data pipeline and see how Databricks simplifies it. Let's assume that your deployment is in S3. And let's assume for simplicity now that all your data is in S3. Then Databricks Cloud allows you to implement the entire pipeline in one place. And you can do that while processing the data in place on S3. It doesn't require you to take this data and move it to another storage system from which Databricks can process it. In particular, with Databricks Cloud, you can do ETL using Spark jobs or notebooks. You can do exploration, data exploration, and advanced analytics using notebooks. You can create dashboards and reports using our dashboard builder. And finally, you can create and run data products using Spark jobs or notebooks you can run as scripts. Of course, Databricks Cloud can ingest input from other storage systems. And in addition, it allows you, through an ODBC driver, to use your favorite BI tool. Next, please welcome Ali Ghodsi, who is leading the engineering at Databricks to demo Databricks Cloud.
OK, thank you, Jan. Is this working? No. This is working? OK. All right. So let me just start by saying, set the stage a little bit. GUI pioneer Alan Kay said, make simple things simple and complex things possible. So that's going to be the theme of my talk. And if you've used Spark, you're already familiar with that. You see much of that already in Spark. However, unfortunately, things that are out there today, even simple things, are really complex, and complex things are nearly impossible to use. Okay? So let me show you Databricks Cloud. So I'm going to log in here. All right. So this is the Databricks Platform. If I click here to the left, I get a menu. Here I have the main concepts in the product. We have notebooks, where you can do most of your development. Dashboards, where you can make pretty things. Tables, where you can import tables, data sets, and do SQL on them. And clusters, where we do all the cluster management. And finally, libraries. In libraries, you can upload programs that you've compiled offline, and you can then use them in the platform. OK, so let's start by just clicking on clusters here. And we see here already that I'm running a cluster. So this is a large cluster. It has about 1 terabyte of memory. And it's running here in the cloud. And it's got about 39 workers. And Spark is running on this. OK, and I can click here if I want to see behind the scenes. You see that there's actually the Spark. For those of you who know or are familiar, behind the scenes, Spark is running on all these machines. It's set up, and you get that full power here. Okay? And if you want to launch a new cluster here, you can just click Add Cluster. So I'm just going to create a smaller one. Let's call it Test, and have it be about 200 gigabytes of memory. And it'll just launch it for you. So just with one click, you get this very simple thing. It just launches a cluster for you. It sets it up. You get the full Spark platform. It sets up all the Databricks Platform daemons for you. Those are daemons that watch, for instance, if one of these workers go down, it'll relaunch it for you. So you have full fault tolerance. It monitors everything. It also sets it up with other things like Tachyon and Hive Metastore and things like that. Okay, so we see now this cluster is up and running, this test cluster, 200 gigabytes of memory, and it's got 7 workers. Okay? Here, we can actually reconfigure it if you want. We can add more nodes to these clusters. We can restart them if something goes wrong with the cluster. And you can also remove the cluster. So this is immensely easier than anything out there. Today, if you yourself want to set up a cluster, this could take you days or weeks, configuring the scripts, getting it up, making sure you monitor it. So we wanted to make it simple, okay? So we have this here. Okay, let's use one of these clusters now. Okay, so I'm going to click here. I'm going to go to Notebooks. Okay, so Notebooks is one of the core concepts in the platform. With Notebooks, data scientists can do interactive exploration. So they can just type in SQL. But also data engineers can use this to program in their favorite language. They can type in Python programs or Scala programs. And finally, a really cool feature that I'm going to demonstrate with Notebooks is that we've actually enabled you to use them as scripts. So you can actually use Notebooks as programs that you can invoke programmatically, and they can invoke each other. So that way you can actually build up a rich library set, but you can also debug them by going into them. Okay, so let's create one. So I'm going to create a notebook here. Let's call it simple. And it's going to be a SQL one. And I'm going to attach it to this larger cluster that we had. Okay, so this is a notebook. In this notebook, I can just type in SQL, so I can say show tables. And that shows me the tables that are already in the product. And here we have a bunch of tables that are related to the World Cup that's going on right now. And I can type in SQL queries, very simple. And this runs directly on top of Spark SQL. So I can say select star from World Cup history here. And it nicely plots the results here in HTML in a table that I can browse through, and I can see what's going on here. So we have here goals, year, continent. Okay? But one of the things we wanted to do is we wanted to really make it simple for you to explore these data sets. A lot of people, what they do is they type these queries, but then they export it to CSV files, and then they plot it in Excel or somewhere else. We didn't want to have that. We wanted to make it really simple here. So you can just click here in the product, and it immediately plots it for you, so you can see the plots. Here, unfortunately, the plot is not the way I wanted it. I wanted to have year on the x-axis, but I can click on plot options, and I can move goals down here, and year up here, and hopefully I get what I want. Okay, so now we see here the results. So we see over the years in the World Cup result, we see the goals, we see that it's been going up in the end of the 90s. Okay, so that's pretty cool. Also in this table, we had these continent data. Okay, so I would like to plot the data in a different way. If I click on plot options, I can actually do pivoting here. So I can take continent and add it here, and then it pivots it. And let's also make it a line graph. And we see here now that we see different continents, how they've scored over the years. And we see that Europe has been scoring most of the goals in the World Cup, followed tightly by South America. Okay, so very simple, one click, Spark SQL, and you get this pivoting. Cool. All right, another thing that data scientists often want to do is they actually want to drill down in these data sets. So they want to say, I want to actually focus on anything that contains America. So let's say continent, and then I say percent America. Okay, and that'll show me the table with just America. I can change it then and say, okay, I can compare this now with Africa if I want, and I see what's going on with Africa. So we wanted to also make this much simpler. Instead of you having to type this, we extended SQL to have support for parameterized queries. So you can just replace this. Anywhere in the query, you can just say $sign and give it a variable name like continent. And what then happens when you run the query is that you get an input widget, and you can here actually interactively just type in Africa, and you see the results for Africa. Okay? This also works on plotting. So if I go here and I say I want this line graph that we had earlier, I can here just say, America. And we see South and North America, and we see that South America has been doing much better over the years than North America. You can also say Africa. And we see that, okay, Africa has been doing much better in the recent years. Okay? All right, so this is cool. But oftentimes, you actually want to share these results with a broader audience. Okay? You want to maybe show it to your colleagues, people who don't understand SQL or don't want to look at the SQL code. So for that brings us to the second concept in the workspace, which is dashboards. Okay? So we can create a dashboard of this very simple. We just click here, and we say we want a new dashboard, and let's call it Simple Dashboard. Okay. And that takes us here. Here we can actually now edit interactively with this WYSIWYG editor here. We can say that we might want to change the term here to not be value of continent, but the search term. Right? You can now actually type things in here. You can say Africa. Okay. And you can also share this. So you can click here. If you click here, publish, it actually opens up another link. So this is a different link now. This link now you can actually email to your friends, or you can embed this page that you see here in an iframe on your home page, and make this much more accessible. All right. Cool. I'll close this and go back here. All right. Another thing that we designed this product from the very beginning with in mind is that you should be able to do collaboration with your colleagues. Okay? So everything that I just demoed to you here, you can actually do at the same time by just sharing this link. If I zoom out a little bit and I create a new browser here, I type it in here, you actually see that everything that's happening over there is also happening in the other screen. So I can say show tables here, and it shows me the table there. If I change if I do a search here, that changes over there as well. Okay, and I can also interactively just add comments here. So I can go up here and say, I spelled that wrong. All right. And if anyone else is using the product and they're logged in, they can actually reply, and we can have interactive exploration of this data set here. OK. All right. So that was simple thing simple. Let me just demonstrate to you by looking at some of the existing notebooks that some of our data engineers actually built. So I'm just going to click here and look at the World Cup one here. So this is a World Cup notebook that someone created. They created some queries, and then they're checking out here whether teams perform better when they're hosting the World Cup. So we see here that that's the case. The blue bar shows that Brazil did way better when they hosted the World Cup than otherwise. Okay? And you can see, in Brazil's case, they score much more for goals than against them. Okay? And you see these things here. There are map widgets, that you can zoom into and look at. Okay. So this is great. Simple things, simple. But this is pretty small data. So I want to do a query on a little bit of a bigger data set here. Okay? So let me start a notebook here. And let's call this big data. And connect it to a large cluster because I need actually a little bit more power here. Now what I'm going to do now is I'm actually going to look at the data set that's already in the memory of the product here. So let me write some notes for myself what I'm going to do. So I'm going to analyze tweets in a 3.4 terabyte data set. Okay, and what I really want to do is I want to plot tweet activity by hour and language. Okay, so that's what I want to do. Okay, so this data set, it's in a table called tweets. It's sitting in the memory of the cluster. It's 3.4 terabytes when it's uncompressed. We've compressed it down, and we have it in memory, and we can do queries on it directly. So I'm going to type a SQL query that does that here. So I can say select. I'm going to say hour of day. And I know that the field for the tweet is called created at. That's when the time that the tweet was created. I'm going to select also language, and I'm going to count the number of articles in that category. And I'm going to take it from this Twitter data set. And I want to filter out. This should be from, and this is where. And I want it to be language in, let's pick a couple categories. English, say Spanish, Arabic, and Japanese, let's say. Okay, and we're going to do group by. And let's group this by hour of day, language. And just to plot it nicely, I'm just going to order it also. So let's do order by hour of day and tweets per hour. I should name these, so as tweets per hour. And here, I'm going to say as hour of day. OK, so this query now is actually running against this in-memory data set that we have in the cluster. And it's actually doing a group by, which actually means that it's actually shuffling all these statistics back and forth to get this, these statistics that I asked it for. Okay? And it's soon going to finish, and we'll hopefully get the results here. All right, some straggler there. OK, so this is the table. We see hour of day, language, tweets per hour. And we can just, again, simply just click here, and it plots it for us. I might want to have a line graph here. Okay, this doesn't still make much sense, so I'm going to move language here and pivot on that. And then we actually can see now. So this is the tweets by hour, and we see that over the course of one day, so the tweets actually cover the whole last week, and it's about 1 billion tweets. But when you aggregate it, you see that English, the red line here, and Spanish, the orange one, completely correlate. So basically the tweeters that tweet in Spanish and English, they go to sleep at the same time and wake up around the same time. Whereas Japanese that are in a different time zone, they actually wake up in inverse fashion here. Okay, and we have some Arabic tweeters here that are active all the time, it seems. Okay. All right. Okay, so this was big data. It was fast. We plotted it. Very simple. But unfortunately, this data set is old. It's tweets from last week up until yesterday. So it would be much cooler if we could actually work with real tweets that are actually coming in live right now. Okay, so let's do that. We can do that with Spark. As Matej mentioned, it unifies all these concepts. So on top of Spark, we have Spark Streaming that lets us actually do tweet streaming live. Okay, so let's create a notebook here for the streaming. Let's call it streaming. And this one, actually, now I'm going to do in Scala instead of in SQL. So we're going to do some programming here. So let's connect it to the large cluster, and let's do some programming here. So here, I can actually type in queries in a Scala interpreter here. Okay, and I'm going to actually paste in this program to save some time. So the program looks like this. And let me just run it here. So what this does is that it basically sets up Spark streaming. So some of you are already familiar with this code. It uses the Twitter utilities that comes with Spark. And every 5 seconds, it actually fetches these tweets. Let me actually change this to 2. I want it to be 2 instead. Okay, and every 2 seconds, it'll fetch these tweets, and it'll create a window of 60 seconds of tweets, and it'll save it to a table in the product called tweets, so that I can actually query it from SQL. Okay, so let's start Spark streaming. So we say Spark streaming context, start here, and it should start this. All right. So this should now start in the background, and the tweets should be dumped into this table. So let's look at that. If we can actually type in SQL here, even though it's a Scala shell, I can mix in SQL here by saying %SQL, and then I can say select star from tweets. OK, so we see some tweets here. Let me scroll by here. Don't focus too much on the text in it. It's unfiltered tweets coming in here. OK, apologies. All right. OK. All right. OK, so let's create a dashboard. Maybe I won't put up the tweets. Okay. All right. Sorry about that. OK, we'll do something about that too. OK, there's a plan for this as well. OK, but all right. Let's ignore this for now. So let's create a dashboard with these tweets coming in. And maybe I should just show some statistics instead of the actual tweets. OK, so I'm going to do select. And I'm going to do select. And I'm going to pick this field that's called create that here, create date. And it's huge, so I'm going to just make it a little bit smaller. Okay, and let's also print a 1 from these tweets. Okay, so it just plots these. So you just see these. This is the number of tweets over different time stamps. Okay, the seconds here. And let's just create a dashboard with this. I'm just going to say create a new dashboard. I'm going to call it tweet dashboard. Okay. And we can go here, and we can see this is the tweet dashboard, OK? And I can actually go here. So dashboards, just like other jobs that you can upload to this, you can have them run periodically. So I'm going to say that I want this actually to refresh every 2 seconds. OK? And then I can go like this. So now we should see that the tweets are actually coming in live. They're streaming in with Spark Streaming. And we have this dashboard that's actually doing this. Every 2 seconds, we're seeing how many tweets are basically coming in here, OK? And you don't see any tweets on the screen. Great. All right. OK. I also want to maybe plot where these tweets are coming from. It would be nice because the World Cup is going on. Maybe we can see if there's more activity in some places. So what I'm going to do is I'm actually going to, for that, I need a function that actually maps these longitude and latitude coordinates that we have in this table to country name. So I just want to demonstrate to you that these notebooks are pretty powerful. You can actually, I've prepared one called setup here. This is an ordinary notebook, and I've written it down like a script. And it just does some things, some setup. It registers some function called get closest country. I can actually programmatically call this as a library. So if we go back to our streaming here, I can just say %run here. And I can run that, notebooks, setup, And it actually runs it now. So it's going to set up these things for me. So hopefully now I have access to that function. So I can actually just now say SQL, select. And then I can actually say here, get closest country. And we give it the lat and the long. And maybe also 1, so that we can count the number of tweets in that country from tweets. And let's filter out those nulls where lat is not null. Okay? So we get this. And we can get it as a map widget as well here. Okay? So we see that there's a lot of activity here in United States and in America. So let's add this also to our tweet dashboard. Right? So here we go. And actually, I can move these maybe up here, have them side by side to be a little bit easier to see. All right? Okay, so we see here. So tweets are coming in live, and we also see the activity. A lot of it is here. Maybe it's a time zone thing, but there's some European activity, Saudi Arabia and Spain and other places. But a lot of it is in the United States of these tweets that are coming in. Okay, so let me go back here. So as you saw, those tweets that I showed you, they were completely unfiltered. Okay, so to avoid more embarrassment, wouldn't it be really cool if we could actually filter these out in some smart way? Okay, to use a little bit of intelligence. So let me stop this here. Let's say refresh menu and go back to our notebook here. So what I'd like to do is actually to do something more complex. So I want to make the complex thing possible. So I want to use the machine learning library that comes in Spark, and I'm going to do some machine learning here to be smart about which tweets I actually show on the screen. Okay, so let's go here, create a new notebook. Okay, and let's call this one ML. And this one is also in Scala, and attach it to the large cluster. Let me write down what I want to do, because this is a little bit complex. So I want to learn a concept based on a search term. Okay? And really, I want to then compare the similarity of tweets with the concept. Okay? All right. So this is what I want to do. I give it a search term. I say FIFA, and it goes off, and it learns everything about FIFA, and then it should filter out anything that's related to FIFA, even tweets that don't contain the word FIFA. Okay? But to learn, we need the data set. So we need to work with the data set. And a really good data set is using an encyclopedia. So let's use an encyclopedia. And for that, let's use Twitter. Okay? Unfortunately, I don't have Twitter in the product here, in the platform. So let me actually import it. And I'm going to demonstrate to you another concept here, which is tables, and how simple it is to import tables that you have sitting elsewhere. So this is an S3 table, and you fill in your credentials here to access that key that's sitting somewhere else. You can also upload local files. And I'm going to give it the bucket name. So I'm going to say Databricks demo datasets. Okay? And what you then immediately get is a file browser that lets you browse the files that are actually sitting on S3 here. So I can go down here and I can click. I know that wiki2 is where this Wikipedia dump, the raw dump of all of Wikipedia is sitting in that directory. Okay? And I can click preview here, and we can see here that it's actually previewing this dataset now. So I can say, I want the table name to be wiki. It's a text file tab separated here. And these are the fields that you see. These are the 4 columns in this dataset. So the first one is ID, which is an integer. The second one is a title of the article. The third one is a modification timestamp. And this one, the fourth one, is the actual text of the actual article. Okay, and the final one is the username. Okay, so that's that. So let's actually create this table in the product. Okay, so we say create. Okay, and this should now show up. So we see now the articles are showing up here in this table here, and there's a table view that you can look at these. Okay, so let's go back to our ML thing here. Let's import this demo package so I can actually access this. Okay, so what I'm going to do now, I'm actually going to use Spark SQL here. So I'm going to say SQL, and I'm going to say select text from this wiki. So I'm going to actually do SQL. And I'm going to store the results in an RDD. So I'm going to say wiki here should be equal to this RDD that contains that. Okay? And now I want to do learning. And to do learning, I want to use an algorithm called TF-IDF. It's a well-known machine learning algorithm for text search. And what I'm going to do is I'm going to create a class, new TF-IDF. And I'm going to say that we have a model called TF-IDF. And I'm going to train this model now, giving it this wiki data set. So you see here, we use SQL here, and we're plugging it into the Scala machine learning library here that's going to actually train on this wiki data set. Okay, so this will take a while, because what it's doing is that the machine learning algorithm on top of Spark is actually now going through all of Wikipedia and trying to learn the importance of these words. So this is a little bit complex. So to explain to you what's going on, let me actually show you a diagram of the architecture here. Okay, so let's have a markdown here. Say we have a image, and the URL for it, if I remember it, is bit.ly Databricks architecture. Okay, so this is this is what's going on here. So what we're doing right now is we're offline creating a model. Okay, so we're taking the Wikipedia dump of 60 gigabytes, using Spark SQL to select those articles. We're taking them into Spark machine learning library, and then we're building a model. And what the model does is this. So this is the important thing what the model does. It learns how important each word is to each article. So for each word, it knows how important it is to the article. And then what I'm going to do next, as soon as this is finished, is that I'm actually going to use this in real time. So I'm going to have the live tweets coming in, and I'm going to store these last 60 seconds of tweets in a table, and then I'm going to actually use this model that we just trained it on to filter out things that I search for live. Okay? So let's see here. This is almost done. Okay, cool. So now I can actually just say model, similarity, and I can give it a concept. So for instance, I can say FIFA, and I can also say soccer. All right? And it actually now, it knows this, so it can actually tell us now how similar these two concepts are. And it actually tells us that the similarity is 0.03. So it's kind of remarkable. That's actually pretty high. So basically, it figured out that FIFA is actually closely related to soccer. Okay, if I change this and I say football, I actually don't know what it'll say. Okay. I can't spell, I know. Okay, that's 0.05. That's even higher. Let's try something else. Let's take wrestling. All right, that's 0. Phew. Okay. Okay, so similarity is working. So now it understands this, and I'm going to do something that I think actually is the coolest thing, and you should really go to Michael's talk where he talks about Spark SQL. What I'm going to do now is I'm actually going to register this similarity function that has its machine learning model in it. I'm going to register it with Spark SQL, and then I'm going to use it in SQL to filter out relevant tweets. So to do that, I just register this function. Okay, so I say register function, give it a name, similarity, and I'm going to give it this function, which is model.similarity. Okay, so that registered it. Okay, and now I can actually just use it. So I can just say SQL select tweet from tweets where, and I can say similarity. Now I can call this function. I say similarity between the tweet, and then let's use a parameterized query. So we just say, search here should be greater than some threshold, and we saw that maybe 001 is a good threshold here. Okay, so we'll get this here, and let me actually add this also to our tweet dashboard and go back to it. Okay, let's move these down and make some space here. So I'll move. This is the search term. This is the activity that's going on here. Okay, I'm going to put the other one higher up here. Okay, and let's go back here and say that we want this actually to run. Let's say every 3 seconds we just want it to run. Okay, and let's go back here. Okay, so now I can actually add the search term here. So we can say FIFA. And actually now, based on what it learned in this model, it should filter out things that are relevant for FIFA. And we know that I think there's a game going on. So, here it's talking about World Cup. I didn't search for World Cup, but it's figuring it out. Okay, this one did have FIFA in it, but not everyone mentions FIFA. Okay, apparently in this slide they do, but okay. But, conceptually, basically, it figures out things that are relevant for this query. It'll actually show you this, okay? So this one didn't have any FIFA in it. So, it's goal and World Cup, and it knows these things, and it can do it. Similarly, I can type in soccer, and it does that, okay? We can also search for other things. So if I actually say, instead of this, I say love, I'll pick, things that are hopefully, okay. Okay, best boyfriend ever. Okay, great. Okay. All right, thank you. So just to summarize, we've done something really complex here. So in the beginning, we did these simple things. We clicked around. It was really easy. But here, I did something that I believe you cannot do in any product out there today. In just 2-3 minutes, we wrote a program that's taking live streams of tweets. We built a machine learning model in Scala. We invoked it from SQL to build a dashboard that live uses this machine learning model and filters out things for us. So I think that's really powerful. And that's the end of my demo. So over back to Jan. Thank you.
So that was great. I hope everyone enjoyed it. So now, one question you are probably asking, it's when it is available, what is the status? So early this year, we have started a closed beta program, and we have already several beta customers. So far, the feedback is very good, which actually many users saying that after working with Databricks Cloud, they will never go back to the previous tools. We are going to announce limited availability very soon, and we are going to gradually ramp up. So please sign up on our site. As you've seen, the Workspace makes our platform usable out of the box, allowing you to build non-trivial pipelines and applications. However, looking farther ahead, we are very excited to run third-party applications on top of our platform. We are already working with several certified Spark application developers to run their applications on top of our platform, refine our APIs. So you should check out Zoom Data Talk and Boot for such an example. So one question is, what is the Databricks Cloud impact? What will be its impact on the Spark community? We believe that its impact will be hugely beneficial. And that's for two reasons. One, Databricks Cloud runs 100% Apache Spark. So there is no lock-in. Any job application you develop and run on top of Databricks Cloud, you can take it and run on any certified Spark distribution, be it on-premise or in the cloud. Second, Databricks Cloud will accelerate the adoption of Spark, as it provides the easiest way to learn and use Apache Spark. So in summary, Databricks dramatically simplify big data analysis. In addition, we believe it will be the best place to develop, test, run, and deploy big data applications. Furthermore, Databricks Cloud will further drive the growth of the Apache Spark ecosystem, and is going to do all of this by making big data easy, easier to use than ever before. Thank you, and enjoy a great